The broadcast is now starting. All attendees are in listen-only mode.
Hello, everyone, and welcome to another Directions Mag Geospatial webinar. I am Barbara Duke, Managing Editor and Executive Webinar Producer, joined by Lynette Qualia, our Assistant Producer. We are excited to have you, and if you have any questions, just drop us a note in the chat. We'll do our best to help you. Appreciate our geospatial community supporting all of our efforts for more than 20 years over at directionsmag.com. We are taking your questions today throughout the session. We will not have a Q&A at the end, but we will share those with the LaserTech team and they will follow up with you personally. We appreciate your input also on the survey on the way out, and you can look for an attendance certificate as well as a link to the recording and some other links in our follow-up email. Also want to draw your attention to your GoToWebinar control panel. They have a couple of good handouts hanging out there for you. Today we are excited to have Derek and Steve back with us, old friends of ours from LaserTech. And they are going to show us how you can do more with the apps and equipment that you have. They understand how important it is to make the most of all the gadgets and goodies in your workflows. So they've got some great suggestions for us today. Welcome, gentlemen.
Thank you.
Thanks, Barbara.
Yeah, thanks, Barbara, and thanks Direction Magazine for hosting this. Really appreciate everybody being on the call today. Just a little bit about LaserTech. We've been in business about 35 years, and so we're located here in Denver, Colorado, just south of Denver, where we manufacture, design, and distribute laser rangefinders. And so we have a support team, service team, all located here in this building. We also have a couple other service centers across the world. One big thing we do is we really focus on our patents to protect our designs, quality through innovation and dedication. Another thing is we do work with a lot of different partners throughout the world. So if you're looking to get a demo of one of these lasers or look for a full solution, you can go to our website and find more information about our dealers and maybe in your area. So today we're just going to talk about field data collection. Several challenges using your GNSS devices, especially busy roadways or private land. So we're going to be talking about, Steve's going to talk about the whole workflow, integrating the laser, what we call laser offset. So you utilize the laser rangefinder with your GNSS device. And then also talk about different mapping workflows. There's a lot of different GIS apps out there. You might already have these, like Barbara talked about. You might have this equipment, might have these apps. So we're going to talk about just to show you the laser interface with a lot of different apps we have. So I'm going to go ahead and turn it over to Steve to talk about just the current data collection workflows.
Thanks, Derek. Good morning, everybody. For those of you that have been out in the field working with a GNSS system and possibly using an app from one of those suppliers or something, you may be familiar with this basic workflow we've got listed here, where you have to walk up to the feature that you want to position, get your GPS in the right location and everything, where you're receiving an acceptable signal and accuracy, key in your all your metadata for the particular point, do your QC and everything, and then walk on to the next point, go on to the next one. So this may look pretty familiar to some of you if you've been out doing this kind of work. So the next slide will show us some of the challenges you might run into out there. You've got to do a manhole out in the middle of a street or something like that. You potentially have to close the road down if you've got to go out there and occupy it for any length of time or just for safety's sake. You've got assets that are underneath tree canopy and things like that are just inaccessible to you. They're across a river or around private property or something. maybe you've got a lot of these different assets you've got to locate in one location. Another inaccessibility down in a trench or something like that. It can be awkward and dangerous to get down into these locations sometimes. And you know, here's a couple other examples of having to get out into busy roadways, but then also obstructions from these tall buildings and things like that. If you get into these areas in urban areas, sometimes you can't access the points directly that you need to. You lose your signal integrity. Or likewise, underneath brush or stuff, you just you try to put the antenna underneath there, and you're just not going to get the accuracy you want. And then, of course, environmental conditions. We talked a little bit about some of those obstructions like fences and of course, and things. But then weather comes into play, dangerous areas, near heavy equipment, and the old barking dog there. Yeah, just a lot of these environmental conditions are tough to deal with out there. So the concept we want to try to introduce you to here is a laser offset, where you don't necessarily have to physically occupy the point that you want to position. You can stand in a safe location there, get your good signal from the GNSS, and then measure distance and potentially azimuth over to the object to put it on your map. We'll go over a couple of different workflows to get it done, but that's the simplest thing to do. Just point and shoot at the object. You've measured that information, done the calculation to generate that remote coordinate.
So yeah, so what integrating that laser rangefinder, what do our laser rangefinders measure? So, you know, it does measure distance. We have that laser sensor that measures distances. So we don't have to have, it's a reflectorless technology. So we do not require a reflector or a prism and we can get the measurements to almost any type of object. Then we have integrated tilt sensor. You can see on the right there, measuring just the angle, the tilt angle, plus or minus 90 degrees to help with other calculations, and also with the just elevation. And then some of our lasers have a compass sensor. With that compass sensor, we're able to measure azimuth or degrees. Azimuth degrees, sorry about that, or direction. So we've got that information there on some of our lasers. So what does that look like? Here's a couple different diagrams. The laser measures slope distance, or SD, or kind of some people refer to it as line of sight. Then the tilt sensor is that INC, or degree of inclination. And that's our 2D lasers that measure slope distance and inclination. And then when we incorporate the compass in the laser, that's a 3D laser rangefinders. So you can see that over on the right-hand side. You've got that AZ value, degree of azimuth. With the press of the fire button, we measure all those values, that slope distance, inclination, azimuth, and then the laser will automatically calculate that BD, or vertical distance, and HD, horizontal distance, automatically. We do have Bluetooth communication, so once it gets a measurement and does these calculations within a third of a second, we do output that information into different devices or GIS apps.
Right, and using those values will get you into creating that laser offset. Either, you know, one shot with the azimuth and distance like you have there, or combining a couple of distance shots. And I also wanted to mention that on board we do have routines for measuring height and missing line, distance between objects, and things like that. So if your particular workflow requires those types of measurements, you can add those in with the laser as well.
Yeah, correct. Thanks a lot, Steve. And so we've got a couple different models. The TruePulse 200 models, they're 2D lasers. You can see the TruePulse 200 and the TruePulse 200X. You see the different range accuracies there. The True 200X is our most accurate laser rangefinder we have. And then you can see the different environmental ratings. I did mention all our lasers have Bluetooth communication. Right now, the TruePulse 200X is the only one that integrates with iOS devices. All the other models we have integrates with Android or Windows. Then we incorporate the compass inside. Now we have the TruePulse 360. Here's the two different models we have. And the main thing on that, this is the azimuth accuracies, half a degree with no pitch or roll limitations. And then also just the environmental on that. You've got two configurations, a vertical and a horizontal configuration. So Steve's going to talk more about the mapping workflows utilizing laser rangefinders.
Right. So chances are, right within one of the apps that you currently use to map with out in the field with your GNSS, you may have some of these methodologies and laser workflows available to you. So the one I mentioned earlier, the easiest is this distance azimuth, where it's just point and shoot with one of the 360 models that will measure the compass bearing and then of course the distance to the object. So, great for out in the field more, in more of a rural setting where that compass is going to be reliable, good for densely populated features and everything. It's just real rapid data collection. So a great option for a lot of cases. And then using the compass, some of the apps will have an azimuth solution where you can see in the diagram here, if you just occupy a couple of points with your GNSS and measure azimuth to the target, it'll find the intersection of those two vectors there and give you your position. So really a handy method in some cases where maybe acquiring a distance might be difficult for some reason. So then a great one for the urban scenario that's pictured here is distance, range type of measurement, where you occupy one position, measure a distance to the object, including a vertical distance so you can track elevation, and then you move, a certain nice, to give yourself a nice geometrical baseline there for good accuracy. You move a little bit, you shoot back to the object. And then the math will calculate a position for it. You just kind of tell it which side of those 2 points you're on, and you've got your point. So again, a great option. Not maybe so great for densely populated features. I mean, if you have a few of them located there, that's what you've got to do, but better for kind of single, spaced, more spread out features. And then the last one here is distance angle, where like the distance azimuth one, it's really just a single shot, but instead of using a compass, which again in this urban scenario may be adversely affected for accuracy, you can use an encoder. So you've got one starting shot to reference it there to a reference azimuth, but then after that it's just a single shot, and again great for high density objects in these more urban settings. So here's some examples. Instead of forcing the antenna underneath the brush, you just stand out and take a measurement to the object. You've got to collect that meter or water feature, whatever that is in there underneath the brush. So you just stand out in the open and take a shot to it. And here's another one. Something was there, but then the vehicle got parked over it. So again, you can't get the antenna right over it. You can stand off in a safe location and still capture the location and elevation of the point. So here's a table we made up just for general accuracies you can expect. So you can see with that single range azimuth method in the middle there, you keep your shot distances down to a reasonable level. That middle column of 50 meters or 150 feet is pretty typical. You're really not adding that much accuracy. The important takeaway here is that you want to budget for this accuracy, right? You're taking that laser shot to increase your efficiency, but you want to make sure you don't blow your error budget by doing it. So make sure you account in for this possible error from the laser, and then add that to your GPS error to stay within budget. But all the different accuracies are listed here.
Yeah, we've got a white paper that you guys can download. It's right here located, ensuring quality GPS laser offsets. So it does a deeper dive about the whole workflow, maintaining the accuracy that Steve's talking about.
Right, it's got this table at the end of it there and everything, yeah.
And so it does lead into like which app is right for you, or you might already have some of these apps. And so I'm just going to kind of touch base a little bit on each one of them. We don't have the time to do a deeper dive, but we have a lot of technical documents on our website to talk about these, show you the workflows. One app that we design ourselves is called MapSmart. Over all the years, we've been working on this and improving an app. It's all for Android based. So we always made it for laser mapping. And so it's kind of just using the laser, using do plot points and lines and polygons and everything with the app. Simple user interface. It's not a typical surveyor software app, so it's really easy to use. But we started incorporating the GNSS receivers into it also. So you could use just as a stand-in plot with that, or you combine the two, like we've been talking about, this whole laser GIS workflow, combining the laser and GPS to maximize efficiency. So got a lot of different ways to export the data. I mean, a lot of different file formats, DXF, shape files, so you can take it into different type of CAD programs. Another app that came out late last year is from Leica, the XENO Mobile app. So it's pretty simple to use, user interface. You can see their different mapping methods Steve talked about. They have 3 different mapping methods. So it depends on which laser you might have that you can incorporate. And so this all goes in here. It's all Android. This is a XENO Mobile on Android. So it's got that horizontal distance, distance, and azimuth, different mapping methods. And you can see the requirements that you have that are needed. So if you have this app and did not know it had a laser interface built in, these are different ways of capturing all the different workflows and remote features. A longtime partner of ours is Trimble. We've been working with them for a long time. They've had a laser interface in a lot of different Windows mobile apps that they've had. With TerraFlex now is all on Android, iOS, and Windows. Their workflow is a little different. It kind of adapts to the user. It knows the accuracy of the laser, accuracy of the GNSS device, and kind of will give you that tolerance that Steve was talking about, that offset tolerance. And if the user needs to get into a better accuracy, you can go into that range or 2-shot offset method. So the user looks at it and says, oh, I need a higher tolerance. If they were using the TruePulse 360, it'll jump right into that 2-shot offset that way. So you see the wizard guides you right through it. It's pretty simple to use. So, but again, you can see the requirements on the bottom here with our lasers interfacing with that. And again, on the iOS, it's just going to be the TruePulse 200X that we interface with iOS devices. And of course, the big guy in the GIS world is Esri. We do have an interface into their field maps, also known as Collector. With this, though, we're using the EOS positioning receiver and their Tools app. Everything's handled in their Tools app, but the workflow is all within field maps. You never really leave field maps. It kind of jumps out to Tools. You do this different workflow that Steve talked about, and then it goes right back into field maps. So they have a range intersect that we talked about. And now what we can do is they have just come out with a product called the EOS Bridge. What this does, it takes a TruePulse 360 that integrates, the Bluetooth module integrates with Android or Windows. Now with that, this bridge will take that information and convert it into, so it can talk to iOS devices. So it takes this information, goes to the bridge, and now you can talk to iOS devices. So you can use it, and no more manual entry on a iOS using TruePulse 360 models. And you can see the different workflows you've got here, the range azimuth, and then the range backsite, that total station type of workflow. But again, this with the field maps, you have to use the EOS positioning receiver in the Tools app for this whole workflow. And then we have a lot of different there's a lot of different apps out there too. We keep finding more and more that have a laser interface. One we've been working with is Prostar Pointman. They integrated the TruePulse 360 into that workflow for that offset, and then Cartopack. They've been working with us for many years, utilizing our TruePulse 200X and the TrueAngle into their workflow. And all these other ones that listed here, not taking anything away from them, we've got a lot of technical documents on our website that you can find that do a deeper dive in all these different apps.
Right.
So
yeah. A lot of these are still on Windows Mobile, and we still have documentation support for all these or anything. So give it a look and see if your app is in there.
Yeah, if you know of any other apps that are not listed or anything, let us know so we can make sure we've got that that we recognize that and make sure we've got a technical document for others out there. Just to wrap up, again, one of our mottos is measure more, move less. Take measurements from a safe location, away from busy roadways or private land, and then you can see the different accuracies you can get on that position with the right laser that fits into your tolerances. We've got a lot of different models, a lot of different workflows to fit into your workflow, and then just overcoming those field challenges. Busy roadway, like I talked about, and all going back to you probably have these devices already. You probably have these apps. Maybe didn't know there was a laser interface, but we've got that information out there. Again, those technical documents on our website. And if you have any other questions or anything like that, definitely reach out to us. You can contact us here at info@lasertech.com, and we'll definitely follow up with everybody if you have any questions. But I really want to thank Barbary and Directions Magazine for hosting today, and also everybody that was on here today. Appreciate your time.
Yes, thanks everybody.
Well, thanks, guys. Always great to have you with us. And just a reminder to our good audience that we will be in touch in your inbox with a link to the recording as well as your attendance certificate. Also, some links that they have shared with us. And don't forget to get those handouts before you go. We hope that you will join us again soon for another webinar, and make it a great day. Hope that you'll tell a friend about Laser Tech and Directions Magazine. Thanks, everybody.